So after I graduated from the Master of Engineering program, I landed my first job in actually software development in an insurance company. So I spent several years building systems and capturing numbers and storing them in a database. In nature, I'm a person who is very, how do I say that, numerical. So I always wondered, what those numbers mean. So that led to, relatively speaking, a smooth transition from building software systems into analyzing data and building predictive models. First, congratulations, because I believe engineers make the best data scientists. So given you are an engineer, I believe you certainly have very solid math background. So what I suggest you to study a little bit is statistics and programming, so computer science. So there are so many great resources on the internet you can go to get introductory stats and computer science materials. Once you get to the introductory material, then you really want to get your hands on real world problems and solving them. So that's why I spend a lot of time on Kaggle, and I recommend everybody who has a chance to do so. Actually, it's very easy for me because I personally feel that I'm much better at approximating things instead of doing very precise math. So, honestly speaking, math is really, really hard subject. So if you're good at math, you should have absolutely no problem doing statistics. I would like to mention my understanding of what does it take to do well in a competition. So first, you need to work really hard. Second, you need to have good understanding of the data and have solid feature engineering in the problem solution. Third, you need to have understanding of the right statistical algorithm. And fourth, you probably need a computer and you be reasonably proficient in writing programs. So I think Kaggle overall probably favors people who have a balanced skill set. So if you are really just very, very good software engineer, but not really good with feature engineering, usually you can't go very far. But the reverse, probably you wouldn't go very far either. So I would attribute my success mostly to one, I try really hard, and two is that I have relatively speaking, a broader skill set. Everybody, doing similar thing that we want to understand the data and make sure that we can validate our model as precisely as possible. So the most important thing in building the good model is that you have a solid validation framework. In Kaggle, the actual validation data set is actually hidden from us. So it's actually quite important for me to create an internal validation process that I can approximate the actual test data. The better I can do that, the more realistic I will have a view of my own models. Beyond that, from statistical approach perspective, the right approach is totally depending on the kind of data. So for smaller data, I rely on mostly linear or generalized linear models. And for medium-sized data, I use a lot of tree ensembles, such as random forest and gradient boosted trees. And for larger data, I use mostly online learners. Actually, the question is easier to be answered as in what competitions the machine learning statistical algorithms are less beneficial. So there are a few competitions in Kaggle. Those are mostly optimization problems, such as the tradition for helping Santa to do some work organization or try to pack the Santa's sleigh. Those are mostly numerical optimization, and so for them, statistics is not very important. But for most problems, whenever you are dealing with data with noise, statistical methods and algorithms are always very important. So as I mentioned earlier, that it really depends on the data size and also the type of data. So for most of the problems, my go-to approach, the first thing I try is really gradient boosted trace. So as long as I can apply the gradient boosted trace, I will use it. I need to work out in about 70–80% of problems. There are other problems, they are very specialized. For example, if it's an image recognition problem, then probably it's unavoidable that you want to try a convolutional neural network. So if it's a sound classification problem, you probably want something very specialized in that domain, which I have no idea of. That's why I couldn't do well in those competitions. So first of all, I have to admit that I'm very competitive in nature, so I like those kind of things. But beyond that, I really like to learn new things from others. So what you can learn from Kaggle, the most valuable lesson is to recognize my own limit. So because if I really work on a problem in isolation, I may get very complacent about, oh, I think I built a great model. Then you put it up there and compare with other people's results, then you realize that there are far better approaches. And the Kaggle community is really a generous community. Many people are very happy to share their approaches, the winning approaches. So it's really after a long and hard struggle about some problem that I can't solve very well, then you look at other people, how they do it, then you say, that's how they did it. I think that's probably the best way to learn. Discipline is what I get most out of Kaggle. So in Kaggle is where it's forced upon us that we have to build models that work well on data we cannot see at all, because the private leaderboard data is hidden from everybody. So in real world, a lot of times the temptation to really cheat, to pick at the answer, is too strong and it's not very easy to resist. But once I get burned a few times on Kaggle, people get burned by overfitting the public leaderboard. Once I get burned a few times, then I really feel that I get that into habit. I always think about what kind of model is more generalizable. Some of you probably know already that I'm working at a startup company in Boston called DataRobot. So here we are really trying to condense what we data scientists learn from solving real-world problems into a software platform that can benefit many people. So I sincerely hope that the company will take off as successful, and then, but after that, what I do, I don't know.